Hello and welcome to this new episode of I Dream of Wise. If you're familiar with Wise, you probably know this section called modulators under the Share Sets tab. In modulators, we can create objects like a modulator envelope and an LFO. Okay, and these two modulators are incredibly useful and powerful when we want to do some real-time design in Wise or to alter some parameters in real time in Wise. And you probably remember that in episode 2 of this series we talked about using an envelope with seek. I really like these two objects, but what I really miss in Wise is a random generator. So if you're familiar with synthesizers, especially modular synthesizers, you probably know what I'm talking about. This is a very basic random voltage generator by Doppler. It has a couple of parameters here, the overall level and the rate at which it creates the random output. So this is more or less how it looks like. The first and second graphs are LFOs. This is a sine wave, this is a square wave. And this one on the bottom is what a random generator looks like. So we have a rate parameter that allows us to change the, let's call it frequency of the random generator, that changes how fast the random generator changes over time. So you can see that at a very low rate, the output is very smooth, but at a faster rate, it changes very fast. Still, it's not an audio signal. I mean, it's not in the audible range, so we can't hear this signal, but we can use to modulate other parameters, like we do with LFOs and ADSRs. So the bad thing is that it doesn't exist in Wise yet, but the good thing is that we can create it. So the idea is to create an audio noise signal, because we can do that in Wise. So we create this audio noise signal and then we track its envelope, because using the meter effect, this super powerful effect called meter effect, we can follow the envelope of whatever signal. So we follow the envelope of the noise signal and then we send that value to an RTPC, and then we use that RTPC to change whatever parameter we want, like pitch or volume or whatever thing of another sound asset or in a bus. So the first thing to do is to create an empty sound effects, and we'll call it noise generator. And the good thing about Wise is that you can have a noise generator as a source. So we instantiate the Wise tone generator, double click on it, and select pink noise. Fixed duration 1 is fine. We set it to loop from the sound property editor. So let's hear how it sounds. Let's bring it down a bit. Okay, perfect. So what we want to do with this noise is to follow its envelope. And to do that, we first have to create an audio bus, and we'll call it dummy. And we have to route the noise generator to this newly created audio bus. And in the audio bus itself, we want to instantiate the meter plugin. So let's create a new Wise Meter custom plugin and go to edit. Let's play the noise generator and see what happens. As you can see, nothing is displayed in here, and that's because, as you can read from here, meter display only works during a capture session for buses in the master mixer hierarchy. So let's start capturing and play. Okay, so the meter is moving. That's a good thing. We want to create an RTPC that receives the envelope that's outputted by this meter plugin. So let's create an RTPC called random. Let's call it just random. And we want to scale the range of this random RTPC to fit the range of the movement. So let's play the noise generator again. So as you can see, it goes more or less from -39 to minus 34. Okay, something like this. Maybe minus 33. Okay, good enough. We also have to remember to change the random range in the property editor of the RTCP as well. So this goes from minus 39 to minus 33. And it's not very important, but let's set the default to minus 39. Okay, so this is perfect. We now have an RTPC that is our random generator. So you may think that now we're done, but actually we're only at the beginning, because, okay, let's try and use this. Okay, so let's create, for example, another empty sound effect. So we'll call it sine. And let's instantiate another tone generator with a sine wave, okay? Well, let's set it to looping first. We want to adjust the frequency of the sine wave with our newly created random RTPC. So let's, for example, draw an RTPC curve that looks like this, more or less. So we have the random RTPC on the x-axis and the frequency on the y-axis. So as the RTPC goes randomly up and down, the frequency of the sine wave should go up and down as well. So set the volume of the sine wave to minus 16, and let's play the sine wave. Okay, so of course it doesn't work right now because we're not playing the noise generator. So we're forced to play the two of them together in order for the random RTPC to generate random values. Okay, so let's create one event. We will create one single event for all objects. It will be called test. So let's play this test and see what happens. So if we manually change the value of the RTPC, we can hear the frequency going up and down, but by itself it doesn't do anything. So how come? This is because from within the Wwise authoring tool, we can't audition changes that involve the meter effect and the attribution of some parameters to an RTPC using the meter effect. So we have to test this inside of a game engine. And for that, I have here a Unity project that's already been integrated with the Wwise project. So first, let's create the sound banks in here. And we already have a sound bank called main. And yeah, our test should already be included in the sound bank. So let's generate. Great. Let's go back to Unity. And in Unity, it's a very simple project. We have a Wwise global object. It loads our main audio bank on awake. And then we have an audio player object that will play our test event on start. Okay? So let's see what happens when we play. Okay, so it works. This is a great first step. The thing is that we can hear the noise that actually generates this random output. And if you remember, we routed that noise generator to the dummy bus. So it should be clear now why we created a bus just for that and why we called it dummy as well. So you may think, well, let's just turn this down to minus 96 and play. It should work, right? Because now if we play the test event in here, we don't hear the random anymore. Turns out that it's not that simple. Let's generate the sound banks and see what happens. Okay, we can hear this super low tone and the frequency of the sine wave doesn't change at all. So this is because if we send an event that tells to Wwise to play a specific object, if that object is lower than a certain volume threshold, Wwise doesn't even bother to play that sound because it thinks like, well, why should I waste my resources to play this sound when you won't even be able to hear it? That makes perfect sense, but it prevents us from getting this random generator to work. So it turns out that if we keep the volume of this dummy audio bus to 0 dB and we instantiate a gain effect after the Wwise meter, and in that gain effect we turn down the level to the very lowest. Turns out that we can trick Wwise in this way, and we can make the random generator work this way. So let's generate the sandbanks and see if... So this is perfect. We hear the sine wave going all crazy, and we don't hear the noise anymore. So this is a great result. We were able to build our own random generator, even if Wwise itself didn't provide one. So a couple more things. Right now this sine wave goes up and down like crazy. And what if we wanted something that was way smoother? For that purpose, we can go two ways. We can edit the meter effect from here. We can edit the parameters for attack, hold, and release. But the way I still prefer doing it is from the random RTPC, from the interpolation setting. So for example, we can introduce a slew rate or a filtering over time interpolation. Let's say, I'm not exactly sure of the parameters I should put in here. Maybe 10 is better. Okay, let's see if this works. Generate the sandbanks. Okay, so the variation of the frequency is much smoother now. It's very nice. So let's think about a real work situation and how we can use this random generator for a sound that can actually make it into a game. One thing I can think about is to create a wind sound. And we can go back to this tone generator that we used to create the sine wave. And we can change the source to be white noise instead. Okay? So let's call it wind. This is now white noise instead of a sine wave. Let's go to the RTPC tab and create a couple of curves. One will be for voice volume. And of course, we will use our random generator, RTPC. And we'll also create a low pass filter curve. And still, we'll use the RTPC called random. So let's go a bit extreme with this. Something like this for the volume could work. And for the low pass, we want the opposite. So something like this. Maybe a curve that's a little bit more like this. Let's audition it. Okay, so this is what I want to achieve. Could be even a bit darker. Oh, well, actually the interpolation was crazy. Okay, I think it should work. We don't even need to rename our events or anything in Unity. It should just work because we changed the sound effects object that was already in there. So let's generate the sandbanks and play. Okay, I'm not sure it's super believable as a win, but I think it's a pretty good result. So thank you for watching. If you have any question, please ask them in the comments, and see you next time.